Hi everybody, welcome to our project. I'm Indy, and today me, Gary, and Martin will be showing you our project, the Embedded Greenhouse. Our system is actually a control system for the greenhouse, controlling two main aspects, but there's actually three circuits. So the first main control circuit is over here, and it is the control valve with a tank of liquid. So there is actually a humidity sensor that would be in the soil of the greenhouse, and as the plant soaks up a lot of the water, the humidity would lower, and as the humidity is lowering, we would want to add some more water, so then the control valve would turn and put more water into the greenhouse. Also, we want to be controlling the temperature of the greenhouse, as there is an LED that gives light, simulating sunlight to the greenhouse, but also making sure that it's not too hot inside of the greenhouse as to create unhealthy conditions for the plant. So there's actually a fan, which as the temperature increases, slowly the voltage for the fan increases, increasing the RPM of the fan and moving a lot of the hot air out. And then we also added the ESP32. This device was originally going to be used as the alarm circuit. It was going to read from the HTML web server, get the data, check if it's above a certain threshold, and then be able to send an email to the operator. But due to memory constraints and the libraries on the ESP32, that wasn't actually possible. So instead we opted for the ESP8266, which actually had plenty of room and all the libraries work just fine, and it can be the HTTP client and also send emails. Alright, so let's take a look at the code. Here we can see the ESP connecting to all the Wi-Fi, setting up the SSID and password, and this is it actually doing the GET request to our web server. And this is checking if the payload is over 30 degrees or if it's in the serial monitor, just for testing purposes. And then all the email building. And so if we check the serial monitor, right now it's just reading 25.3 degrees because it's not actually being updated. But if we hit the reset pin, we can actually see the board trying to connect and then telling us that it's up, has an IP address, and so we can actually simulate a high temperature and by just entering H or any character into the serial monitor. And soon enough it should send an email. So this is all the code of it sending the email. And then if we check my email, you can see that we just got a brand new email sent 0 minutes ago. Temperature readings are high. And so this is where you can see all the temperatures, and if you go to the most recent, this is actually the page that it reads from. It's just the temperature. And yeah, that's the alarm circuit. And now Gary will tell you about his circuit.
Hello, my name is Gary, and this is the video explanation of my circuit and how it works. So at the beginning you can see it's attempting to connect to my hotspot. You can actually see the debugging codes on the video recording of the circuit, the live video recording of the circuit itself. Temperature is fine right now, 23.30. I must add, for this experiment we are trying temperatures. We are looking for temperatures above 25 and under 30, and that's what the server knows, and that's what the circuit is designed for. So right now the temperatures are fine. We are getting live view on the website, and the tables are being added. The queries are being added to the table. Yeah, so in a second I'm gonna blast the circuit with my heat gun to control a high temperature for it. People are gonna see a intense rise in the temperature soon, and it's just gonna happen in just a few seconds. So as you can see, the temperature just went rose very fast. We are now above our comfortable temperature, which is 30. We're going into the 40s. Again, you can see we have live view on it on the website. The blue line on the graph is, which is again, it's an online website. You guys can go to it right now. Anyone from anywhere in the world, as long as they have internet access, can access this website and look at the graph. And the blue line shows the temperature. The black line is the humidity, and the green one is actually the fan voltage. Now for this fan didn't have a speed. Some fans come with a separate wire that's showing the speed of the fan. This fan didn't have it, so I manually calculated the voltage from my PWM output. See, I think I've stopped using my temperature heat gun right now, so the temperature is going down. Yes, the temperature is going down with the help of the fan. Again, we have live view, everything's being coded into the table, then showed on the graph. And the fan's gonna be full 5 voltage, which is the max for this specific fan. You can have a 120 voltage fan as well, just because I'm using a MOSFET, and because it acts like a relay, so there are two different circuits. So you can have a very high voltage fan. If you want to connect it to the same, it's going to be the same thing. You just have to have a good enough power supply that can help the fan move. And if you've paid attention from the live video recording, which I'm gonna edit in, it's gonna show the debugging LEDs on the circuit. A clicking blue is it's just one blink. A blue LED means the data being posted to the server. Uh, a short red one and a long red one means there was a post failure. A constant red means we're above 30, and red blink, blue blink, red blink, blue blink continuously means the system is trying to connect to the Wi-Fi. As you can see, the fan helped the circuit to cool down well under 30. We're still going down. The fan still is taking voltage, but it's a lot lower than 5 because again, the circuit is designed to save energy. So the fan is not always full blast. It only goes to the full blast when needed, so we can have a comfortable temperature. Thank you very much. I will pass this to my next teammate,
who is Martin, and he will be describing how his humidity circuit works to water the greenhouse.
Okay, so here is my ESP, my MOSFET connected to 10 volt or 12 volt power supply with 10 amp, and my 12 volt 3 amp solenoid globe valve here with the water coming out there. I also have my soil moisture meter in the water here to simulate a saturated plant. I will take it out of the water now to simulate when the plant is unsaturated, and that will cause the valve to open. So I will start taking the thing out now. When it comes out, you can hear the click from the valve, and you can see the water starting to come out the side of the valve. When I put this is on timer, it will eventually turn back off. The soil moisture meter having water in it will have no effect on the circuit. I obviously don't have it down now, but the valve, you should be able to hear it close soon. Alright, that was the valve closing, and that is the basic operation of my valve portion of our greenhouse.
That has been the embedded greenhouse. Thank you for watching.